Now we will go to discuss about the steam turbines. In this steam turbine topics, we will go discuss about the types of turbines, impulse and reaction principles, velocity diagram, work done and efficiency, optimal operating conditions, multi-stage compounding, multi-staging and compounding and governing. These details are we will go to discuss about this today's presentation. Next, the turbine is defined as that it is a prime mover in which the potential energy of the steam is transformed to the kinetic energy. Later, it tends to transform to the mechanical energy of the rotation of the turbine shaft. This classification of steam turbine, the principle of action of steam, based on that impulse turbine and reaction turbine. And based on direction flow, it is divided into three classifications, that is axial flow, radial flow and tangential flow. Number of stages, single stage and multi stages, and based on that governing, that is nozzle governing, throttle governing, bypass governing, and combination of these three, that is throttle, nozzle and bypass governing. That is the steam turbines, Pelton wheel and rotor and nozzles diagram. Here we will do the impulse turbines. Next we will discuss about that impulse turbine. It's a type of steam turbine where the rotor drives its rotational force from the impact force, that is the direct push of steam on the blades. Okay, the impulse turbine first built in 1883 was Swiss engineer Lee Lowell. The impulse turbine consists of rotor mounted on the shaft, that is free rotation. The rotor are set of curved blades. The nozzles injected at the steam at high pressure, high temperature steam. That touch steam hit on the blades of the turbines. That is the difference between the, that is diagram for the impulse and reaction turbines. Impulse and reaction turbines. The red color is nozzles and it is blades, moving blades. Here fixed blades and moving blades. The velocity is gradual, that is here velocity is suddenly reduced. In impulse turbine pressure is maintained at atmospheric pressure. In reaction turbine, the pressure is gradually reduced. Each and every stage, the pressure is gradually reduced. The reaction turbine, that is a gradual pressure drop and takes place continuously over the fixed and moving blades. The function of the blade, that is act as a nozzle, that is alter the direction of steam as well as allow the expand to the larger velocity. As a steam passes over the moving blade, its kinetic energy is absorbed, that is due to kinetic energy is absorbed by them, that is due to fall in pressure. In moving blade, where are the same shape as the fixed blade is same shape of the moving blade, it is mounted on the outer casing where the set to guide the steam into the moving blade. That is a reaction turbines. The first one is the steam enters through the section of the curved blades in fixed position. The second position 2, that is steam then enter the set of moving blades and creates the enough reactive forces to rotate them. Third one, steam exits the section of rotating blades. Fourth one, in the direction of rotation. This is a simple diagram of the reaction turbine blades. Next one, the difference between the impulse and reaction turbine. In impulse turbine, nozzle and moving blades are in series. In reaction turbine, fixed blades and moving blades are in series. In pressure falls in nozzle. In reaction turbine, pressure falls in moving blade. In impulse turbine, velocity of the steam increases the nozzle. In reaction turbine, kinetic energy of the steam is increased fixed blade. Impulse turbine, compounding is done to increase their efficiency. Reaction turbine, no compounding is necessary. The pressure drop per stage is more, but pressure drop is less. Power developed is more in reaction turbine. In impulse turbine is less. Efficiency is high in reaction turbine. The efficiency is low in impulse turbine. In impulse turbine, low phase is required, but in reaction turbine, more phase is more space is required. That is the difference between the impulse and reaction turbine. Next one, compounding. Compounding of steam turbines is the method of which energy from the steam is extracted in a number of stages rather than the single stage. That is, stages increased to reduce the RPM of the RPM of the rotor. The compounding steam turbine has the multiple stage. That is, it has a more than one set of nozzle and rotors in series, key to the shaft or fixed to the casing. The either steam pressure or jet velocity is absorbed by turbine in number of stages. The velocity of the high velocity of the steam is allowed flow through the one row blade. It produces a rotor speed about the 3000 rpm, sorry, 30,000 rpm, which is too high for practical use. So not only this, leaving the loss is also very high. So first problem, the single stage means the rotor velocity is very high, that is 30,000 rpm. It is so very high, it is practically impossible. It is not too safe, and also the leaving the loss also very high. Therefore, to essential to incorporate to improvements simple impulse turbine for practical use to achieve the higher performance. This is possible by more than one set of nozzles, blades, rotor in series to the common shaft. Either steam pressure or jet velocity is reduced by the in stages. So that is losses also reduced. This process is called compounding of steam turbine. That is called, the diagram shows the compounding of steam turbine. The number of stages are there. That is called shaft, fixed blade, rotor blade. So number of stages are there. So the velocity the velocity also reduced, the rpm of the rotor also reduced, pressure losses also reduced. Next one, three type of compounding. First one is velocity compounding, second one is pressure compounding, third one is pressure and velocity compounding. The rings of moving blades are separated by rings of fixed blade. The moving blades are keyed towards the turbine shaft. The fixed blade is casing. The moving blade separated by the rings of fixed blade. Moving blade is fixed on the shaft, another the fixed blade is fixed on the casing. The high pressure steam coming from the boiler expanded the nozzle first. Nozzle converts the pressure energy is converted to kinetic energy. The high velocity steam is directed to the first set of moving blade. As the steam flows over the continue the shape of the blade, it impacts the reduce the velocity, losses of some velocity. That is the velocity compounding. That in nozzle, one moving blade, and fixed blade and moving blade. So the pressure is constant. The velocity is gradual, stage by stage, the velocity is reduced. This is called velocity compounding. Next one, the one part of higher kinetic energy is absorbed by this blade, the remaining the exhausted on the next ring of blade. The function of the fixed blade is to redirect the steam leaving from the first ring moving blades to second ring of the moving blades. There is no change in velocity and it is passes through the fixed blade. It is until practically all the energy has to be absorbed. The advantages of this velocity compounding is requires comparatively small number of stages due to relatively larger heat drop per stage. Small stages means initial cut is less. So 2 or 3 row wheel is okay. The steam temperature is low. Hence the cast iron cylinder may be used. Disadvantages: high steam consumption, low air efficiency and high steam consumption. Next one, we will go to discuss about the pressure compounding. It consists of the alternative rings of nozzles and turbine blades. The nozzles are fitted to the casing and the blades are keyed to the turbine shaft. In this type of compounding, the steam is expanded in the number of stages instead of just one nozzle. In the velocity compounding, the fixed blade which act as a nozzles, the expands equally at all the rows of fixed blades. The remaining from the boiler is fed to the first set of blades. The steam is in partially in the ring, nozzle ring. Next one, pressure compounding. In pressure compounding, nozzle, that is fixed blade and moving blade. That is each and fixed blade and moving blade has a one set and another stage. There is one stage, another stage, another fixed blade and moving blade. Here in this diagram, three stages are there. This pressure is gradually reduced. Each and every stage in the pressure is gradually reduced. And in the partially decrease in pressure of incoming steam, this leads to the increase the velocity of steam. Therefore, pressure decreases and velocity increases in partially in nozzle. That is so in diagram. This is then passed over the set of moving blade. As the steam over the moving blade, nearly all the velocity is absorbed. Hence, in the pressure remains constant. Okay. Next, in the process is repeated until condenser is reached. Next one, plus pressure and velocity component. The combination of ever two compounding, total pressure divided into the number of stages. Total pressure drop is divided into the number of stages. Each stage consisting of fixed blade and moving blade. Each set moving blade is separated by the single ring of fixed blades. The fixed blades are act as a nozzle. That is called velocity, pressure and velocity compounding. That is each and every stage the pressure is equally reduced. Next, the pressure partially decreases, velocity rises correspondingly. So, in the following moving blades until reach the next ring of the fixed blade, the whole process is repeated once again. That is governing. The steam turbine governing is produced of procedure for controlling the flow rate of the steam into the steam turbine so as to maintain the steam of the rotation at constant speed. The governing means that to maintain the constant speed of turbine irrespective of load. Irrespective of load, in the variation of load during the operation, the turbine can be a significant impact on the performance. So, practical situation, load frequently varies from economic load and varies from the peak load to and economic load. Thus, there is always considerable deviation from the desired nature of the performance of the turbine. The primary objectives of the steam turbine to maintain the constant speed of rotation irrespective of varying the load. This can be achieved by the governing of steam turbine. The type of steam turbine, throttle governor, nozzle governor and